Students will be able to graph cosecant, secant, cotangent, and tangent. Graph two periods of each equation. Here we're going to graph cosecant. So we're going to start out by graphing sine. 1, 2, 3, 4. Here's 2 pi. And 1, 2, 3, 4. Here's negative 2 pi. So we got an amplitude of 1. So there's 1 and negative 1. And then we're going to graph sine. So here's sine. I'll make it dotted because we don't really want to... Our final answer is not sine. Our final answer is going to be cosecant. So there is sine. Now anywhere cosecant, or anywhere sine is 0, cosecant is going to be undefined. So we have vertical asymptotes. Anywhere sine is 0. Now the reciprocal of 1 is 1, so they're going to share the 1s and negative 1s. And there's the graph of cosecant. And we just turn sine upside down. Like that, and turn it upside down here. Next we're going to graph 2 secant of x minus pi over 4 plus 1. So we're going to graph cosine. Yeah, we're going to graph cosine. 1, 2, 3, 4. 1, 2, 3, 4. Here's 2 pi. Negative 2 pi. We have an amplitude of 2 and we're going to go up 1. So 1, 2, 3. Amplitude of 2. So let's do this. Let's go negative 1 and negative 2. Now we're going to graph cosine. So let's just do cosine with an amplitude of 2. So here, midline down there, midline up here. And we're going to do the same thing on the other side. And we want an amplitude of 2. Now, hey, well, here's cosine, and this should be nice and curved, actually. Like this. Now we're going to take that and we're going to go right pi over 4. Now we have to decide how much is pi over 4. Well, this is pi, and this is pi over 2. So half a space to the right, and then 1 up. Half a space, 1 up. Half a space, 1 up. Half a space, 1 up would be here. Half a space and 1 up would be right there. And then half a space and 1 up. So here's the newest and latest cosine. And then half a space, 1 up. Half a space, 1 up. Half a space, 1 up. Half a space, and 1 up. So there. And it's kind of hidden right there. And that should be nice and curved. A little too jagged there. But now anywhere, now we went up 1, so anywhere this blue is crossing this midline right there, we're going to have vertical asymptote. So there's 1. There's another one. And another one is right there. And another one is approximately right there. Now we're going to turn the blue upside down. Here, and I almost forgot one on the end here. Like that. Like this. Turn that upside down. Turn this upside down. And finally a little piece on the end there. Here we have cosecant, so we're going to graph sine. 1, 2, 3, 4. 1, 2, 3, and 4. So negative 2 pi back here and 2 pi here. Up 1, and we got down negative 1. Amplitude is 1. The period has not changed. So now let's just graph sine. And I'll just stay with blue here. Here's sine. So like this. Here, and then down here, back to 0, up here, back to 0. There we go. Now we got to go right pi over 2. This is pi. And 1 space is pi over 2. So we're going to go right pi over 2 and down 2. So down to -2, down to -3. Let's change colors here. Let's go to green. So right 1 space and down 2. Right 1 and down 2. Right 1 and down 2 is here. And let's just note that the new midline is right there. But so we're over here 1 and go up 1, back to 0, and down 1. How about we do it like that? And then we got to push this one over 1, and that's back to here. Just like that. And then down here, down here, back to 0, up to 1, back to the midline. All right, now anywhere the graph hits the midline, cosecant is going to have a vertical asymptote. There, one there, and one right on the end. Whoops, there we go. And now we need to turn all of that upside down. So like this. Over here like this. There's one. And here's one on the end. Graph tangent of x. Well, let's start out by looking at the unit circle. And so tangent at 0, let's see, we have the point 1, 0. So at 0, 0 over 1 is 0. And then at pi over 2, we have the point 0, 1. 1 divided by 0 is undefined. That's a vertical asymptote. And then down here, if we go to negative pi over 2, this is the point 0, -1. So we're dividing by 0 again for sine over cosine or y over x for tangent. And this is undefined. So we're going to have some vertical asymptotes for tangent as well. Now, tangent is sine over cosine. So let's graph cosine. We're going to graph the denominator. So we're going to be up here at 1 and down here at -1. 1, 2, 3, 4. 1, 2, 3, and 4. So -2 pi and 2 pi. And we're graphing cosine. So this will be down to -1, back to the midline, up to 1. Midline, -1, 0, 1. So this is cosine. Now anywhere cosine is 0, tangent is going to be undefined, or there's going to be a vertical asymptote. So there's a vertical asymptote here, vertical asymptote here, another one at pi over 2. We'll investigate that a little bit. Another one here at 3 pi over 2. So notice that at pi over 2, this is pi over 2 right here, there's a vertical asymptote because tangent's undefined there. And then at negative pi over 2, we also have undefined. So this is actually negative pi over 2 right here. Now, some other spots that we're interested in is the tangent of pi over 4 is 1. So halfway here, this would be pi over 4, tangent's 1. And then negative pi over 4 is -1. So negative pi over 4, halfway to pi over 2, is -1. And then if we were to graph a bunch of points, it curves to this, and then it curves up like that. So that's how it curves. Now I wonder if we can bring up Desmos and show this. Move the mic a little closer. So I'd like you to see a nice version of tangent of x. So tangent of x, there we go. See the nice smooth curves to 0, and then 1 and -1. I don't want to restore. Let's go from -2 pi to 2 pi. Steps of pi over 2, let's say. And so now here's pi over 4. we have a nice value of 1, negative pi over 4, a value of negative 1, and we have this nice smooth curve. Well, that's what this is supposed to look like. So there's one period of tangent. So every time we go in between these asymptotes, that's another period of tangent. So it should be this nice smooth curve. And then going up to infinity and down to negative infinity here. And then there's going to be another half a period at the end here, and this will go to 0 like that. And then there's another one over here, negative 1, 0, 1, and it does this nice smooth curve like that, and then goes up to infinity there. I'm doing this on a tablet, and so it's a little hard to graph on tablets. There, like that. Let's graph cotangent, and if we look at the unit circle from 0 to pi, the point over here is 1, 0, and cotangent's 1 over 0. Cotangent's sine over cosine. So now on this one, we're going to graph cotangent, and if we look at the unit circle from 0 to pi, this right here at 0 is the point 1, 0. Now, cotangent is cosine over sine, and so cosine over sine, cotangent starts out right away as undefined or has a vertical asymptote, and then over at pi, we have negative 1, 0, so cotangent's undefined at 0 and pi. But we want to graph sine. We want to know where sine is 0. That's where we'll have those vertical asymptotes. So 1, 2, 3, 4. 1, 2, 3, 4. Now sine will have an amplitude of 2. Let's go up 2 and down 2. So negative 2 to 2. This is 2 pi, and this will be negative 2 pi. Now we're going to have to go left pi over 6, but let's not worry about that right now. Let's just graph sine with an amplitude of 2. So 0, 2, 0, negative 2, 0. And then negative 2, 0, 2, 0. Well, now let's figure out how far we have to go to push this pi over 6. This is pi over 2. So pi over 6 would be right there. So if we're going to go left pi over 6, that's not very far. So how about right there? Here, here, left pi over 6, and left pi over 6. So then here, there, a little bit over, and a little bit over. Now, anywhere sine, anywhere sine touches the midpoint, cotangent is going to have vertical asymptotes. So there's another one right here. Another one, and one more right there. Now, cotangent goes 1. Cotangent of pi over 5, actually, that's pi over 4 is 1. 1, and then up at pi over 2 is 0. And then 3 pi over 4 is negative 1. So it goes 1, 0, negative 1. So let's get a different color here. And we're going to go 1. 0 is now in the middle between these two blues. So let's say right here, and then negative 1, or in this case, 2 and negative 2. And then it curves like tangent. It's upside down from tangent. So it's like this, and then another one. I need halfway between the blue. Let's call it there. Halfway between that, halfway between that. We'll call it that right there. So this is cotangent, another period of cotangent. Need halfway in between the blue. Let's say it's right there, and halfway between there, and halfway between there down at negative 2. Because remember, we've multiplied those 1s by 2. So there's another period of cotangent. How about one more over here? Let's say that's halfway, half of that, and half of that. And cotangent is upside down from what tangent is, but they look very similar except upside down. Let's 2 and pi over 6. Let's go 2 cotangent, and we'll do minus pi over 6. And that's what ours looks like roughly. Let's graph this negative tangent 2x minus 1. And so we're going to graph negative cosine of 2x minus 1 because tangent is sine over cosine. We want to graph the denominator. So now the period is 2 pi over 2, which is equal to just pi. So 1, 2, 3, 4. So here's pi, 1, 2, 3, and 4, negative pi. And an amplitude of 1. 1 up here, negative 1 down there. And we're going to graph negative cosine and then push that down 1. So if we said that this was now the new midline, then we're up here, there, here, and here. There, down, back to midline, and up here. Now, anywhere this touches the midline, the tangent is going to have a vertical asymptote. So here's another one here. Another one. And one more right here. Now, remember we've done negative tangent, which makes it look like cotangent because we've turned it upside down. So we have the 0, and now instead of 1 here, we got negative 1. So like that. Halfway in between would be here. Halfway, halfway, and now our tangent graph has been turned upside down. So it looks like cotangent. So there, halfway, halfway. So we got the 1s and the negative 1s. So another full period of tangent. Here, here, and here. Like that. And one more little piece here and here. Like that. Graph the function y equals 3 sine of x from negative 3 pi over 2 to pi over 2 only. So 3 sines. So 3 up here. We'll make this negative 3. 1, 2, 3, 4. We'll call that 2 pi. 1, 2, 3, 4. Negative 2 pi. And we want to find negative 3 pi over 2. So here is pi. Here's pi over 2. So from negative 3 pi over 2 to pi over 2 right here. And we're graphing sine. So 0 to the top, and we go back this way, back to 0, and back to the top. So we only want from negative 3 pi over 2 to pi over 2. Like so.